Alright, hi you guys. Today we will be talking about quadratic equations. Okay, and quadratic equations are just the equations that come in the form of ax squared plus bx plus c equals 0. Okay, huge thing is important is that you have the 0 over here. Why? Because of the fundamental theorem of algebra. And the fundamental theorem of algebra says if a times b equals 0, then a or b must be 0. Okay. In other words, if we take something like this and we actually try to solve it normally, try to work backwards and everything, it's not going to work the same way that we're used to. But if we do something, like for example, if we solve it by factoring, so let's say we had x squared minus 3x, let's go plus, let me see, 40 equals 0. Okay, the only way we could actually solve this by hand is to actually factor it, which is x minus 8 and x plus 5.
Alright, well, if I don't see you, have a wonderful trip to Seattle.
Equals 0. And this actually should be, and I'm just realizing this right now, sorry about that, this should actually be a minus. This is what happens when you make up problems on the fly. You tend to make little mistakes. Okay, so we have this all set up. Now, this is, if you pretend this is A and this is B, A times B is equal to 0, so that must mean that x minus 8 equals 0, or x plus 5 equals 0. And if you solve both those equations, x is equal to 8 or negative 5, you'll actually find out the answer for this type of problem. Now that's solving by factoring, so that one's pretty easy. Now sometimes this side is not going to be 0, so if you just get it to be 0 by doing the opposite operation and get all three terms over to this left side, you should be good. Okay, so that's that one. Now if you go to the message board and look up factoring, the factoring flowchart that I've put up there, you should be able to find some other ways of solving by factoring, and sometimes they're as simple as, something like this: 2x squared minus 10x equals 0. Okay, and you get done factoring and you get 2x parentheses x minus 5 equals 0. Okay, and you get something that looks like this. And what you do is you set up each part still equal to 0, because now the a is the 2x and the b is the x minus 5. Okay, and when you solve it, you should get x is equal to 0 or 5. Okay, so that's greatest common factor, and there's also some other ways on there, like solving by the AC method. Oh man, I hate this. I always have to look this up. Okay, I'm back. Alright, so I had to go look up the problem because doing these ones on the fly don't work as well. So let's say we had 9x plus 4 equals 0. Okay, now this one's tough because you can't do greatest common factor, so you have to do what is called the AC method. Here's A and here's C. And what you do is you multiply both of them. 2 times 4 equals 8. Okay, and what you do is you get rid of the 2 in the front for a little bit, so you go x squared plus 9x plus 8, and this is a little bit of combination of, this is definitely a math trick. It's the AC method. I find it to be easier than the diamond or the x that you guys might use, but so be it. Okay, so we get rid of this 2 for a little bit and we replace this 4 with an 8 now. Okay, alright, now we can actually factor this, so we get x plus 8 x plus 1 equals 0. Okay, and what we do is we actually bring that 2 back in and put it in front of each x, so this is 2x plus 8, 2x plus 1, Okay, and then you just factor it out wherever you can and get rid of it permanently. So I factor out the 2 out of both of these parts, so this becomes x plus 4, 2x plus 1 equals 0. And then you just solve it. So x plus 4 equals 0, or 2x plus 1 equals 0. Okay, and you'll find out that x is going to be equal to -4 or -1/2. Okay, so that's solving it by hand and using factoring. Okay, so that one's pretty simple. Now, if you were to do a table, okay, or if you were to actually use a graph here, let's just go ahead and use the graph. Okay, so we have our graph right here. Okay, what you would do is you could actually just go ahead and use the graph. Y equals x squared minus 5x. Let's go minus 14. Okay, so what we do is we look for the x-intercepts, and they're right there. Voila, you actually have it. It's really nice. Now what you could also do too is you could do a table of values to find out where x is going to be. Okay, and wherever the y value is 0, that x is your answer. So this would be one of our answers. Okay, now since we have the graph, we kind of have a cheat way of doing it. Now if you notice, it's getting negative down here. It's getting more and more negative, so it just kind of has to come back up. So we put in a 3, 4, and as you can see, it's coming right back up. 6, 7, and there we go. We actually have our others. Now you might have to put in decimals sometimes and actually do this, and you might have to put in like 100ths of the decimal to actually get this. But wherever y is 0, that x is your answer when you're looking at a table of values. Okay? So that means that -2 and 7 are actually answers for this, which actually match our x-intercepts, which makes sense. It's kind of cool how that works that way. Alright, now when using this too, you can actually graph some really cool measurements and stuff. So -16x squared plus 224. Okay. Alright, now, oh, excuse me. Quadratic. Kind of have to zoom out a little bit. So let's make our x table. Our y-axis is good, so let's make that a step of like 1. It's not going to actually do it, so that's not cool. Alright, so let's say that we have something like this. Let's actually make this a little bit smaller so we can see it. There we go. Okay, so let's zoom in. Okay, it's not as easy to see. Alright, so normally okay, something looks like this. There we go. Alright, you're going to have 3 points of interest. Well, actually a couple points of interest. Okay, this first point right here on the y-intercept. Now, if you were to model a motion in real life of someone throwing something, okay, this would actually give you the gravity. This is the force due to gravity. This is the force due to the velocity, the initial velocity of the object, and this is due to the initial height. So those are those 3 numbers, A, B, and C of the quadratic equation. Alright, now, you're not starting at 0, 0, because if you notice that is right there, and we actually measure in time. So we can't have a negative time, so we actually have to start at 0. Now this just means that the person or the thing that launched this was initially had a height of 5 feet. Okay, so that's kind of cool. Now, here's the other cool thing. I can actually tell you by knowing these information, I can actually tell you the height and the time the object gets to, the maximum height. So the maximum height this object reaches is 161.3 feet after 3.1 seconds after its launch from a height of 5 feet. So this went an additional 156.3 feet, which is really cool. Now, is everything going to have a parabolic motion? No. If you toss it straight up in the air, it still is represented by this. Okay, but this just, if you pretend that the x-axis is time and the y-axis is height, it'll make all kinds of sense. Alright, now this last number right here, it is 0. That's initial height, or that's not initial height, that's just the height of 0. Okay, and if you notice, it's 6.3. Okay, normally these bad boys should be symmetric. That's not helping at all. Let's go 6. Let's make that 7. I want to get this as close as possible. 8, 10. Oh, that's just not getting close at all. Okay, normally these times should be about half. They should be half of this total time. Okay, but if you take a look at this right here, our 6.3 is representing over time. That tells us how long the object's been in the air. So the object has been in the air for 6.3 seconds. Okay, it spent about... Now here's the tough part, is like, how long has it spent up in the air? Okay, you have to look at the symmetry over here. So what we do is, that's at negative 0.1, okay? All right, and this is at 0, so it spent that much time up in the air. Now, has it spent, this is actually kind of interesting. If this had started at 0, which it doesn't for some dumb reason, okay, this would be half of this number. And if you notice, it's 3.1 and this was 6.3, and if I zoomed in, I got 6.35. Okay, so that's an issue. That's not actually half. That's because I had an initial height. If I actually get rid of this part, there we go. Now it's going to be a little bit of half. So this is really kind of cool how this works. Okay, so this will be actually twice the time it takes to get to the top. Okay, now that's not exact. That's actually Desmos rounding it. It's probably 3.125. Okay. But you guys can know that when you set up this stuff, that whatever this total time is, if you take half of it, you can actually get to the maximum height the object reaches. And that's very helpful in finding maximum height and just understanding that parabolas are very symmetrical and they're very nice and they make a very nice picture. Okay. That is it for quadratic equations, and you could actually tell that this object spent 6.3 seconds up in the air and it reached a maximum height of 156.25 feet, and that was after 3.1 seconds, which is halfway point between the beginning and the end of the fall. Okay, if you guys have any questions, please feel free to email me. Otherwise, I'll talk to you later.